Okay, we know how to find the inverse of a function when it's defined as a finite set of ordered pairs, right? You just flip all the x and y coordinates around. But most of the functions we deal with in algebra and calculus are defined using formulas, right? So the question becomes, well, how do you find the inverse of a function defined using a formula? So that's what we want to do in this example. F of x equals 3x minus 4. Find the inverse. Okay, first thing we should check, the only time we talk about inverses is if the inverses are functions. So we should check to see if this thing's one-to-one. Let's write down some steps here. Check to see if it is one-to-one, to see if f, or whatever the name of the function is 1 to 1. And one easy way to do that is to graph it. So here's some review for the final, you guys. F of x equals 3x minus 4. Let's graph that thing. What kind of function is it? It's a polynomial function. What's the degree? 1, so that makes it a special polynomial function. Which kind? What does it graph to be? A line. It's linear. It's a linear function. So mx plus b, right? What's the y-intercept? -4, so 1, 2, 3, 4 on the y-axis, down. And then what's the slope? 3, so up 3 over 1. 1, 2, 3 over 1. Or you could go down 3 and left 1. And you don't have to have a great graph here, so I'm not going to get out my straight edge tool. Is that thing going to pass the horizontal line test? Is it going to be 1-to-1? Yep. So I want to see the graph. I want to see maybe a few, I can't draw an infinite number of horizontal lines. It has to be true for an infinite number of horizontal lines each line has to only go through one point, at most one point, for it to be 1-to-1. So draw me a few of them and show that it's obvious that any horizontal line would only pass through one point. And then you would say it's 1-to-1 by HLT. Actually, I'll put it right here. 1-to-1 by HLT. And it's obvious, from the graph. Otherwise, if it weren't 1-to-1, you wouldn't find the inverse. Or you'd have to restrict the domain to make it 1-to-1. Okay, number 2, once you've verified it's 1-to-1, okay, the following steps are a recipe for finding the inverse function. You're going to, first of all, so that the symbolism is easier to deal with, you're going to replace f of x with y. So replace f of x with y. So in this particular problem, we're going to make it y equals 3x minus 4. But the directions in blue apply to finding the inverse of any 1-to-1 function defined using an equation like this. Okay? So the directions in blue give you the general method, or general recipe. So we've got y equals 3x minus 4. Okay, what did we do up above when we found the inverse of the finite set of ordered pairs? What did we do with the ordered pairs? We switched them all around. We can't do that here because y equals 3x minus 1 is a line and it represents an infinite number of ordered pairs. But what can we do symbolically? Good, we can switch x and y. So that's the next step in the recipe. Switch x and y. So in green, for this problem, that gives us x equals 3y minus 4. The next step, we always like y by itself when we're talking functions. Y is f of x, so we solve for y. Solving for y is the next step. So step number 4, solve for y. And then for this particular problem, that means, okay, we have x equals 3y minus 4. If you like, you could put the variable that you're solving for on the left side. 3y minus 4 equals x. So what do? Add 4 to both sides, get 3y is equal to x plus 4. Divide both sides by 3. So I think, or multiply by 1/3 might be a better way to think about it. So how about 1/3 x plus 4/3? 1/3 times 4 is 4/3. We're almost done. That's essentially the inverse function, 1/3 x plus 4/3. The last step is to use the proper notation. So we're going to replace y with, okay, the proper notation, you use the f superscript -1, that means f inverse, and then function notation parentheses x. So replace y with f inverse of x, and that's just function notation. The name of the function is f inverse. That's the f superscript -1. The parentheses x is the usual of x notation for functions. When you see this, you just say it as f inverse of x. And so you get f inverse of x is equal to the 1/3 x. Whoops, I was doing this part in green, so let me be consistent with that. So for this problem, you get f inverse of x is equal to 1/3 x plus 4/3. And that's your answer.